I buy and test all the weird solar stuff so you don't have to. As I mentioned in the last video, when buying my solar setup, I populated my cart with all kinds of solar goodies. That last video was about buying and thoroughly testing a true solar-powered 2-ton AC unit. If you haven't seen that video, I'll link it down in the description. But poking around Signature Solar's website, I stumbled across this chargeverter thing. At first glance, I was like, why would I need this? My inverter can charge my batteries from a generator. Then I thought a bit more about it and checked out its specs and thought, well, this might come in handy. So I bought it. For reference, at the time of this video, it'll cost you $465. And I've greatly underestimated how useful this thing really is. Since my place is still under construction, I've used it a lot. And the more I use it, the more I realize that this thing is absolutely a must-have for any solar setup, but it's particularly invaluable for an off-grid setup. So we're going to go ahead and thoroughly test this thing under a number of conditions. These tests should pretty clearly illustrate how it can save your bacon in ways that your inverter alone couldn't. And then at the end of the video, I'll go through the specifics of how the chargeverter can save you literally thousands, both upfront and long-term. And if you come to the same conclusion I did, I'll put a link down in the description where you can buy one along with a discount code. Before we get into the testing, let's do a quick primer on how this thing works. To wake it up, you either apply power through the generator port, or you just flip on this breaker. It's connected to your batteries, and it goes through its boot up process. So here you see the battery voltage is 52.7, 52.8. It's kind of bouncing around. Current right now is 0 amps, obviously, because it's not charging. And SOC stands for state of charge. That is lost because we do not have the Ethernet port connected to the comms ports of the batteries. You normally wouldn't do that anyway. You would connect your comms ports of the batteries to your inverter. So this is how most people would use it. To change settings, you hit the enter button, and there's your voltage that tells you like what the peak battery voltage should be. You hit the down arrow to go to the next one. Now, if you are using the state of charge settings, you can start and stop here. But if you're using just the battery voltage settings, which is what most people will use, you will see battery start and battery stop. Right now it's 52 volts to start charging and 57 volts to stop charging. But to change settings, all you do is you hit enter, and then the down arrow will let you select which digit you want to change. And let's say we want to change this to 53 volts. The up arrow is the only way to change the actual digits you have to cycle through. And then we would hit enter. It won't take it. Why? Because it's 52 to 57 volts. Now, if I wanted to start it at 51 volts, we would hit enter, go to the next digit, and cycle through to 51 volts and hit enter. It took that. But, you know, that's a bit of a wide swing, so I'm just going to set that to 52 volts. So the charge current is 70 amps right now. Let's scroll down to that. You can set that anywhere from 1 amp to 100 amps. 70 amps is a good, it's like a 70% load of the max rating of this thing. I like to keep it there. It works well. And we are going to be changing that number quite a bit when we do our testing. One other really cool feature of this thing is it can send a signal out to start the generator should the battery voltage drop below your set point. Let's move on to the fun and do some tests.
Eeny, meeny, miny, mo, I wonder where my plug will go. Big Jenny 5K 240 volts. The chargeverter takes the charges up like Usain Bolt.
All right, let's start with the big one. The big one is rated at 6,000 watts, but that's 6,000 starting watts. All generators do this. You can see it's 6,000 starting watts, 5,250 running watts on gasoline, and on propane it's 5,500 watts starting, and then 4,750 running watts. But that's where you're going to save some money because the chargeverter can take in 5,000 watts when it's charging at 100 amps. I don't like pushing my electronics that hard, so I have it set for 70 amps, and using Ohm's law with the reduced voltage of 50 some odd volts, 70 amps works out to be about a 4,000 watt draw out of this thing, about 4 kilowatts. But this is how easy it is to use. Let's just connect her up. Here's what a 30 amp plug looks like. The ground is at the top, neutral is at the bottom. You have leg 1 and leg 2 on either sides. But this is what's important. This is where your 240 volts are. So all we got to do is plug her in. So let me just turn this thing on. And it wakes up. Gas is full. Let's start it. Okay. You can see we're up and running. It's putting out 245 volts. That wakes the chargeverter up. Current voltage is 51 volts. We've set it to start at 52 volts. But now it's just showing the output of the chargeverter, but since the breaker is still off, there's no power going to the batteries. To fix that, all we do is throw the breaker. You can hear the generator load down a bit. Starts at about 16 amps of current once it stabilizes, and then it starts to go up slowly, which is nice, which is what you want. You don't want to slam your generator with 70 amps or 4 kilowatts of draw all at once. And these cables here are simply connected to the bus bars in the battery banks. Speaking of battery banks, let's take a look. Just for grins, let's wake a few up. It's showing charging, 2.3 amps and climbing. Charging, 2.5 amps and climbing. Charging and 3.1 amps and climbing. And it's going to keep climbing as the charge current climbs. It takes a good minute or so to get up to full power. But that's it. It's just that simple. Since all the batteries are basically hooked up in parallel, you're going to get a full charge. Now as the generator is getting loaded down as we approach 70 amps, it gets louder. It gets noticeably louder. But we are at 70 amps. Here we go. We've peaked out. Let's see how our batteries are doing. And this one is currently charging at 5.3 amps, 5.2 amps, 5.4 amps, 5.5 amps. And the rest of them are doing the same thing. Incidentally, I have tried this thing on propane. It does work. There's a tank I used. It ran for about 3-4 hours on that tank. At about 5 amps of charge rate, you're looking at 20 hours to fully charge these things with that little draw. But realistically, you're never going to go from completely dead to completely full. But that is another benefit of the chargeverter itself. If you have one battery that's dead, you can just hook this thing up to just that one battery. It'd be very difficult to do that with your inverter. This thing has a lot of cool tricks, and you're going to see why it's worth buying and why I bought it. Before we look at the generator output, let's establish a baseline. And for that, let's use the inverter. First, let's check the voltage and the frequency. Let me just plug it in. So we're measuring the voltage straight out of the outlet here. This is coming out of the inverter. It's 60 hertz and 121.8 volts. Now I've connected this little oscilloscope to a transformer because, well, honestly, I don't have a proper ×10 probe to work with this thing. So I need to step the voltage down, but it will at least allow us to see the actual shape of what is supposed to be a sinusoidal waveform coming out of this thing. So let me just connect the scope and see what it tells us. And there you have it. It's sinusoidal. It does have a little bit of artifacting going on, but again, this is straight out of the inverter itself. This is what everything in the building will see from here on out. 60 hertz, 121.8 volts, and a waveform that looks like that. Now let's look at the output of the big inverter generator. I have the other end of this extension cord plugged into the inverter generator, obviously a 120 volt socket, because there's no easy way for me to do the 240. But this will still give us an idea of the quality of the power coming out of the 6,000 watt inverter generator. And of course, we're going to compare that to the smaller inverter generator as well as the really cheap one. And there is going to be a difference, I promise. But let's go ahead and plug this thing in and hopefully the probes don't fall out. Okay. Basically 60 hertz, 60.1. Okay, I'll take that. That's pretty consistent. And 120.9 volts. Now let's take a look at the waveform coming straight out of the generator. I will say, this actually looks a little bit better than what comes out of the solar inverter. This is almost a perfect sinusoidal wave. Looks good. It's a benefit of an inverter generator. The big one works.
where my plug will go. Small Jenny, low pole, 120 volts. The chargeverter takes it, but charges slow. But at least it works in a pinch.
One of the benefits of the chargeverter is that it can take in anything from 120 volts. It's probably a universal power supply, which probably means 100 volts, but don't quote me on that. But anything from 120 volts to 240 volts. The beauty of that is that you don't have to have a 240 volt generator, which is great because it can get you out of an emergency in a pinch. But having said all that, this is very important for your safety and mine to know how this thing is wired. So here's a receptacle for a 30 amp plug, and the ground is on top, neutral's on the bottom. You've got one leg and another leg. So between these two legs, you'll see 240 volts. Between the neutral and this leg, you'd see 120 volts. And between neutral and this leg, you'd see 120 volts. But this is a normal plug. Do not use a normal plug. It won't work. But let me show you why. Okay, so ground, obviously, let's start with the ground. So ground connects to ground. And there you go, ground to ground. Neutral will connect to probably this one. Yep, there's your neutral. Okay, so now one of these two legs is going to go to the other pin here. Yep, got it right first try. So this is how a normal plug is wired. And since the chargeverter's inputs are on these two pins, not between here and here, you need to make a special adapter cable to do this. Let me show you the one I made. So this thing's a little bit big to fit entirely under the camera. You're just gonna have to trust me. This is one continuous cord. Once again, 30 amp receptacle, regular 120 volt US and I believe Canadian plug. Let's see how I wired this. The way this should be wired is the ground is at the top. That will correspond to that ground. And then one of these pins will correspond to one of the legs and the other one will correspond to the other leg. So basically anything, if you plug this into a generator and plug it into anything that is expecting 240 volts, it ain't gonna see it. It'll see 120 volts. So you'll just be underpowering whatever it is. But this is what's needed for the chargeverter. Let's double check to make sure I actually connected the ground. And there's your ground, it's connected. Let's check one of the legs. It's that leg. Let's check the other one. Just to be sure I got this right. Yep. So there you go. This is the kind of cable, and you're gonna have to make this cable, so it means you're gonna have to buy a receptacle. It's actually cheaper just to buy a heavy gauge extension cord and cut the end off and roll with it from there. Now let's go test the first 120 volt Jenny, the little inverter. One of the things I love most about this generator is how easily it starts. Just turn the knob to on, choke it, pull it. It's a one-pole wonder. So the little Harbor Freight Predator is a 1400 watt starting, 1100 watt running generator. As you can see, it's powering up the chargeverter. It's pulling roughly 31.5 watts to do it. Let's start loading her down and see what its limit actually is. So once again, we go into the menu. We definitely have to pull this down from 70 amps. Let's start with, I don't know, 10 amps. Okay, there we go. Let's throw the breaker. We're climbing. 400 and 500 watts, 538. 10 amps, it's doing it. All right, that clearly works. 641 watts is 10.6 amps. Let's crank it up some more. Let's go to 15 amps. It unloaded the generator. Oop. Get out of here. And it's building back up. 4 amps. 5 amps, 6, 10 amps. You can hear it load down. Come on, baby. 15.2 amps, 910 watts. We're getting up to the limit. Should we try, I don't know, 17 amps? Let's try 17 amps. But I mean, how cool is this? We're charging our batteries off of a tiny generator, perfect for an emergency situation. Let's say your main generator goes down. You can't do this with your inverter. You need something like a chargeverter to pull this off. Again, 912 watts, 15.2 amps. Let's get back in the menu. Let's try 17 amps. 17 amps is 1,034 watts. We're still holding. Still haven't popped the overload light yet. We are 64 watts away from its max rating. Should we try 18 amps? 18 amps is 1,100 watts exactly. Generator's still holding. No overload light yet. Let's see if Harbor Freight pulls through. Still holding at 1,100 watts. I mean, this is a lot harder than I would want to push this thing. 17 amps is probably where I would cap it. Do we dare try 19? Let's try 19. 16 amps, 17, 18, 19, 1,000. Oh wow, that's almost 1,200 watts. Oh, overload just kicked on. So 1,200 watts. Kudos to Harbor Freight. Starts easy and does support its rated power output. Like we did with the big generator, let's see what the little inverter has to offer in terms of voltage, frequency, and quality of power. Let's plug her in. On voltage and frequency side, frequency, once again, 60, 60.1, pretty good. Bit of an overachiever on the voltage at 124.1. Let's look at the shape of the waveform. Look at that. Also a perfect sinusoidal wave. Doesn't get much better than that. Let's move on to the non-inverter generator and why you should save your money and buy a smaller inverter generator rather than a larger non-inverter generator. I'm fine plugging my electronics into this. Let's see how the other one works with the chargeverter, and then we're gonna see what it looks like here.
Eeny, meeny, miny, moe, I wonder where my plug will go. Old Jenny, dirty power is no fun. But the chargeverter takes it. I tested, but it doesn't run.
Now, I know the song says it doesn't run, and it didn't. I lent it to a contractor who broke it. I've had this thing for 15 years. It was the first generator I ever bought. But me being me, I fixed it, and we are gonna test it. Let it clear its two-strokiness out. Purrs like a kitten, smells like a crack whore. Well, clearly the backlight doesn't like the power this generator is putting out, but the chargeverter seems to have no issues. This is one, honestly, I've not tested yet, so I don't know. Yeah, I think this thing actually killed my watt meter. Let's go to 5 amps. Okay, there we go. Building back up to 5 amps. 5 amps should be about 300 and something watts based on what we saw off the Predator. Oh, listen to that puppy cycle. Jenny doesn't like it. Chargeverter does. It's charging at 5 amps. It'll take forever to charge 1,200 amps worth of batteries. or 61 kilowatt hours, which is what I have here. But it will get you out of trouble. Little generator's finally settled. Now I spoke too soon. Let's see if we can get to 10 amps. I doubt it. There we go. Come on, buddy. Give me all 600 and something watts. We're at 5 amps. 7 amps. It's taking it. Watt meter's not. Nope. Well, it works. It will get you out of a real problem, but I wouldn't want to use it. But if you are royally screwed, it'll work. I got the other end of the extension cord plugged in. Let's see what this Jenny does. Okay. Frequency's a bit all over the map. So is the voltage. If that doesn't illustrate why you should always go for an inverter generator, I don't know what does, particularly in this day and age when everything has microcontrollers in it. Let's look at the waveform. That is, in a word, ugly. That's very ugly. I don't know if it's even worth repeating. You get the gist. I'm going to zoom in for a tighter shot of this. This little oscilloscope has been with me through a lot, so forgive the screen, but look at that waveform. Just look at it. That's not even a waveform a mother would love. Moving on.
Meeny, meeny, miny, mo, I wonder where my plug will go. Meeny, meeny, miny, mo, when there's Roger, he's a dog. Come here, Roger. Hey, where you going? Come back, Roger. Roger, come back.
The chargeverter is pretty gosh darn cool, isn't it? And yes, I'm still having fun with my AI music bot. If rap isn't your thing, there's a moment of Roger coming up with what I think is a really killer song. But back to the chargeverter. Here's how it can save you thousands. When you have a solar setup in your home, cabin, whatever, you basically have a giant UPS that can power your heavy current draw items. That means you can buy a significantly smaller backup generator. Since you only need to be able to put out enough energy into the batteries in a 24-hour period than you would pull out of them, plus some overhead to take care of daily electrical draw. For example, if you have an AC unit that pulls 5,000 watts and a hot water heater that also pulls 5,000 watts, you won't need to buy a generator that can put out that combined power, which would be 10,000 watts. Your inverter and batteries can handle that. A 5,000 watt generator can put out 120,000 watts or 120 kilowatts over a 24-hour period. For even large homes, that's enough to put 60 kilowatts into your batteries and give you 60 kilowatts of usable capacity over a single day. So you can forget about needing a giant, expensive, and heavy whole house backup generator, saving you literally thousands. And a smaller generator is portable, so you can take it with you in your RV, camping, or in my case, field production, since the generator I have is about 100 pounds. Try doing that with a whole house Jenny. The one I have costs about $1,000. I'll link it down below if you want to give it a try. I could literally replace it 5 or 6 times for the cost of a whole house unit. Also, my generator can run on gasoline or propane. Most stationary big whole house generators require natural gas or propane, but won't run on gasoline. In an emergency, it's usually easier to find gasoline. Heck, you could siphon it out of your car or your lawnmower if you have to. While finding a propane truck to deliver if roads are impassable or if your area is suffering the after effects of a storm could be impossible. Same if your natural gas main gets damaged. And the chargeverter will allow you to maintain your batteries in ways your inverter can't. You can charge up a single troublesome battery. You can slowly charge your batteries for maximum life. You can use virtually any generator with this thing. But really, I think the test that we did will give you countless ideas on how the chargeverter can be used. And if you have a really big battery bank, mine is 61 kilowatt hours just for reference, you can run 2 or 3 chargeverters if you wanted to speed things up. Now let's cue up the band, and I'll see you all in the next one. Ready?
Charge 'em up, run 'em down. Charge 'em up, run 'em down. Chargeverter.
Good boy. Come on.
Living off grid is hard enough. Yeah. Generator choices make it tough. Yeah. Charge 'em up, run 'em down. Charge 'em up, run 'em down. Chargeverter. When the sun doesn't shine enough, yeah, you need bring that voltage up. Yeah, charge 'em up, run 'em down. Charge 'em up, run 'em down. Chargeverter. Living off grid is hard enough. Yeah, generator choices make it tough. Yeah, charge 'em up, run 'em down. 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 Chargeverter. And Roger goes. Woof. 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 Bop, bop. Woof, woof. Chargeverter.